Hello everyone. I welcome you all to my lecture, part 4 of my lecture series on centrifugal compressors. We'll start with what is work factor. Everybody please concentrate on this graph. As you can see, there are two lines, right? I have already explained this graph in the previous video. Now 1 2 dash is the isentropic process and 1 2 dash 1 2 is the actual work done, right? So work factor is the ratio between actual work input divided by Euler's work input. Now Euler's work input per kilogram is given by VW2 U2. You know that, right? Now actual work output is given by Cp delta T, that is T2 minus TO2 minus TO1. Clear? This is per kilogram, so we don't have to take M. Next is pressure coefficient. It is a ratio of isentropic work by Euler's work. That is, we have to take this part. We'll consider this process 1 2 dash. So the isentropic work is given by Cp TO2 dash minus TO1 divided by VW2 U2. But we have the isentropic efficiency as TO2 dash minus TO1 by TO2 minus TO1, whose derivation I have described in the previous class. So TO2 dash minus TO1 is given by this equation, right? So we'll substitute this in equation 1. So we'll get Cp isentropic efficiency TO2 minus TO1 by VW2 U2 is equal to 5P. Now we'll assume that the impeller plates are radial. If it is radial, we can write VW2 is equal to U2, that is beta will be 90 degree. So it becomes U2 square. So we can write, you already know what is work factor, right? So we'll substitute that also in equation. We'll rearrange that and write this equation, that is Cp TO2 minus TO1 is equal to 5W VW2 U2, where 5W is the work factor, and we'll substitute equation 4 and equation 3, and finally we'll get this equation. In this we'll cancel U2 and we'll get as isentropic efficiency into 5W into W2 divided by U2. This is the equation for 5P. But we know VW2 by U2 is equal to slip factor. So finally we'll write it as pressure coefficient is equal to isentropic efficiency into work factor into slip factor. Clear? So next is surging and choking. Surging and choking are two of the main problems that we come across in centrifugal compressors. To explain what is surging, you have to look into the graph. This graph we have on the y-axis we have pressure ratio and on the x-axis we have mass flow rate. Okay, this shows the variation of pressure ratio with the mass flow rate of air. Clear? Now, every compressor has an optimum working condition. By looking at the specification of the compressors, we'll decide a impeller speed and a pressure ratio. Let's just say S is the design point. It is the optimum working condition. Clear? Now I'll mark where is S. Now S is the optimum working condition. It is called as a design point. Now what happens when we decrease the mass flow rate? Now say we have a compressor. From the outlet of the compressor it goes into the delivery valve or a control valve. From the control valve it goes to the receiver tank. I'll denote it as T. Now let's just say okay, clear, right? So at design point the flow of gases will be towards this side, right, from the compressor towards the tank. Now when we are going to say decrease the mass flow rate, what happens? When we decrease the mass flow rate, what happens is the pressure ratio increases up to Q. Till Q, the pressure ratio increases. Okay. Now that is called as surge point. Now after that, what happens is beyond Q, if we decrease the mass flow rate, what happens is the pressure ratio decreases, as a result of which the pressure on the compressor outlet side decreases and pressure on the tank will be high. As a result, the reversal of airflow takes place. And when the reversal of airflow takes place, the pressure on the compressor starts slowly increasing and pressure on the tank gets slowly decreasing. And after a point, again the reversal of flow takes place, and this gets continued for a number of cycles of high frequency. And this process is called as surging, and it will cause physical damage to the compressors, and it will also cause high frequency vibration as this cycle gets repeated with very high frequency. This whole process is called as surging. I hope you are clear with the idea of surging. So next is choking. So what is choking? So please concentrate on the graph. So let's just say in this case we are actually increasing the mass flow rate. Now what happens when we increase the mass flow rate keeping the impeller speed constant? Now when we increase the mass flow rate of air, the pressure ratio decreases. When the pressure ratio decreases, it reduces the density of the air. As a result, the velocity of flow increases, and also V2, absolute velocity at the exit, also increases. Clear? Now, as a result, we can see a decrease in the characteristic curve, and it reaches a point called as choking point, beyond which we won't be able to increase the mass flow rate.